All right, we are moving on into chapter 3. We spent a whole chapter on solving equations, solving proportions, looking at some real-world situations. How do we use algebra to solve for unknown things? How do we solve for the principal? How do we solve for the time? How do we solve for commission? And now we're going to be looking at when things are not the same. All of chapter 2 is on equations. It was equal. When will this phone company be the same, equal to this other phone company, or these taxi rides, or all these different situations where we wanted to know whether they were the same. In chapter 3, and again in chapter 6 actually, we're going to be looking at what happens when they're not the same. Because sometimes things are bigger than each other, or they're greater than each other, or they're not the same. And we're going to call those, and I'm sure you've seen this before, but we can call those inequalities. So you're going to fill that in on your notes. Inequalities compare things when they're not the same. And we use these symbols. You've seen them before, but I'm going to review them really to make sure. The first one here in the top left-hand corner is less than. I don't know how you want to remember it. I know some people remember it by saying, well, let me try to get my pen working here. It eats the bigger number. And so you can put teeth in there, and it eats the bigger number. Or it points at the smaller number. This one over here then on the top right would be is greater than. It points at the smaller number. So you would say, I'm just going to pick some random numbers. Let's say 2 is less than 5. So there's that is less than symbol. Or 5 is greater than, there's that symbol, is greater than 2. Those on the bottom, you've probably seen them, but I can't guarantee it, and I don't remember exactly what you saw in 6th grade, and you maybe don't remember what you saw in 6th grade either, so I'm going to review it. The 2 on the bottom here have this line underneath them. So we've got the is less than sign, but there's this line right there. That line is kind of a combination of is less than and equal to. So a mix of that less than sign and the equal sign. And we say that it is less than or equal to. How that works is 2 is less than or equal to 5, because it's one or the other, or. It is less than 5, so that is true. However, this is true as well. 5 is less than or equal to 5. Because of that or word, it gives us more options. It's either less than or it's equal to. Both will work. Of course, this would not work for either one. 6 is not less than 5, and 6 is not equal to 5. So 6 is not less than or equal to 5. You could have either 5 or you could have 2. And the one on the bottom right is greater than or equal to. And we're going to look at how those or equal to symbols affect things here in just a minute. But that's your refresher on those inequality symbols. Is less than, is greater than, is less than or equal to, is greater than or equal to. It eats the bigger number. It points at the smaller number. Okay, graphing. We're going to be doing some graphing in this chapter. It's not graphing ordered pairs. If you remember like graph paper, it's not graph paper. It's graphing on just the x-axis. So we don't have an x and a y-axis. We just have an x-axis. We just have a number line, which is a graph. It's a one-dimensional graph. We're going to graph this inequality. So it says m is greater than or equal to 3/4. Now let's see. 1.5 is greater than 3/4. 2.5 is, or 2.25, excuse me, is greater than 3/4. 3 is greater than 3/4. All the numbers over on the right side there are greater than 3/4. 0 is not greater than 3/4. 0 is less than 3/4. So I know that any number over here, go ahead and draw that arrow. Any number over here and beyond, 4, 5, 6, 7, 9, 500, 11 billion, are all going to be greater than m. They're all greater than m. So we're asking what values, what numbers could we put here in m where this would still be true? Right? We could put 1.5. That would be true. We could put 3. That would be true. We could not put 0. That would be false. M could not be 0. So we're going to have lots and lots and lots and lots and an infinite number of answers for this problem. Because m could be anything greater than 3/4. I'm spending a lot of time on this explanation, so you get it. Now, here's the tricky part. the number 3/4. You'll notice that I put my arrow line here very close to 3/4, but not quite. And we're going to look at what happens then at exactly 3/4. So the problem is, or the question is, could m be 3/4? Is 3/4 greater than or equal to 3/4? Yes. 3/4 is not greater than 3/4, but 3/4 is equal to 3/4. And the way we denote that is we have a filled in circle right on 3/4 there. It means that 3/4 works in this situation. So look at another one. Got this problem here. T is less than 5, parentheses 1. So we're going to solve. We're going to get it down to one number first. We're going to evaluate, excuse me. We're going to get this evaluated down to one number. -1 plus 3, we got 2 and 10. So T is less than 10. You may have to do some evaluating to get it down to one number first. Now we can graph it. T is less than 10. Well, let's see. I'm going to look at my graph here. I've got my number line. T is less than 10, so I know -2 is less than 10. I know 4 is less than 10. I know 8 is less than 10. 12 is not less than 10. So T could be 2. T could be 4. T could be 8. T could be -8. T could be -500 billion. T could be any number less than 10. So all these numbers are less than 10. How about 9? 9 isn't on the graph, but 9, yep, 9 is less than 10. How about 9.5? Yep, 9.5 is less than 10. How about 9.9? Yep, 9.9 is less than 10. 9.999. How about 9.9999999999999? Yeah, all those would be less than 10. It's really hard to graph 9.9999999 and forever and ever and ever, and ever, a long time. Right? That's hard to find on my graph. So the way we show that, well, actually, before I say that, but how about 10? If I put 10 in here, is 10 less than 10? No. There's no equal sign underneath. 10 is not less than 10. It's equal to 10, but this symbol that we have doesn't say or equal to, it just says less than 10. So 9 point, a whole bunch of 9s, I won't say it again because it's annoying, is less than 10, but 10 is not. So the way we graph that it gets really, really super-duper uber close to 10, but not quite 10. It doesn't quite get to 10. It just gets super-duper uber close to 10 as we draw an open circle over the number 10. That open circle shows us that there's a hole at 10. It gets really super close to 10, but not quite 10, because it doesn't quite equal 10. So an open circle, not equal to 10, but really super close. Closed circle, like in this first one here, means that 3/4 does work. It gets super close to 3/4, and we get 3/4 as part of the answer as well. So going back here to this first page, next to these symbols, and you can certainly leave the numbers on there if you want, but next to these symbols, we'll go ahead and have you put, if there's no line underneath, like these first couple here, open circle. If there is a line underneath, if it's greater than or equal to, we've got a closed in circle too. So is less than is greater than, open circle. Is less than or equal to is greater than or equal to, closed in circle. And the reason we have the open circle versus the closed circle is because of these situations, where 3/4 does work, so we close in the circle. But since 10 doesn't quite work, but 9.9999999 does work, we have to have a way of graphing that. And so we get it really super close to 10 and draw an open circle. Try these two on your own, graph the inequality. Before I have you try it on your own, maybe let's talk about drawing the graph. What I need you to do to draw a graph at the very bare minimum is have 5 lines on your graph. Whatever this number is, go ahead and put in the middle, 2.5, and then you can go up by any scale you want. You can go up by 10s, you can count by 1s, you can count by 0.5s. So this 2.5, I'm just going to count by 1s, so I'm going to go 3.5. 4.5, but I don't care what scale you go by. You could go 2.5, 3, 3.5. We put a couple numbers on either side. Again, you can count by whatever, you can count by 100s if you really want to, but pick a scale and go with it. I went by 1s, but that's what I went by for that one. So now if I'm graphing it, C is greater than 2.5, Well, 3.5 is greater than 2.5. So I know that any number over here is going to work. Any of those numbers, 3.5, 4.5, 5.5, they will all be greater than 2.5. And since there's no equal sign underneath it, since 2.5 is not a solution, I have an open circle. 2.6 works, but not 2.5. Okay, try this next one on your own now that I've talked about how to create the graph. All right, so I'm going to assume that you tried it. So 2 squared is 4, minus 4 is 0. So W is greater than or equal to 0, or excuse me, 0 is greater than or equal to W, excuse me. So now I'm going to make a graph. There we go, 1, 2, 3, 4, 5. I'm going to put my solution, 0, right in the middle. So 0, I'm just going to count by ones again because why not? Okay, so W is W is less than or equal to 0. 0 is greater than or equal to W. Well, what numbers could work here? If I put 1 in the answer, 1 is not less than or equal to 0. 0 is not greater than or equal to 1. So 1 is not a solution, which means that my arrow is going to have to go that way. 0 is greater than or equal to negative 1. 0 is greater than or equal to negative 2. And since 0 is greater than or equal to 0, if it's equal to 0, we can close in that circle and say that 0 is a potential solution. I'm going to stop here, and I'm going to let you watch a different video so you can take a break from it and move on to a different video in just a minute.